Hello everybody, today I would like to introduce you to the NanoAssembler Blaze, the machine we use to scale up our nanoparticle production of formulations that we develop in the Li Lab. So this machine uses rapid microfluidic mixing that combines two liquid streams and forces nanoparticle production via self-assembly. So before we start producing our particles, we have to prepare two separate liquid streams. So on the one side, we have an organic phase that is typically an organic solvent that contains our lipids that will eventually make up our particle. On the other hand, we have our aqueous phase that consists of an appropriate buffer system and may sometimes contain a drug or a nucleic acid in the case of solid lipid nanoparticles, for example. So for the production of our particle, the Blaze will draw both of the liquid streams and combine them in the microfluidic chip that sits in the center of the machine. Within this chip, there is a microscale flow path that has a certain geometry and allows for rapid, precisely controlled mixing of the two phases. And as the liquids pass through this flow path, the polarity of the solution will gradually increase, and that increase of polarity will drive the formulation or the assembly of lipids into the final nanoparticles. And if you take a quick look to the interface of the program here, we're able to control the production parameters such as the total flow rate as well as the flow rate ratio of our two liquid streams. And in doing so, we're able to control the particle size and end up with high quality particles that we can use for in vitro as well as in vivo testing. Hey everybody, so today I'd like to introduce the lyophilizer or freeze dryer that we use in our lab. So this is a gigantic machine, but what it essentially does is it dehydrates or removes water from our samples. So what it is based on is a process called sublimation, which transitions a substance from its solid phase into a vapor phase, or in our case, water into water vapor. So it's based on principally three steps. First, we have to freeze our sample. Second, we will apply a vacuum at low temperature, which turns ice into this vapor state. And then the third is removing the water vapor from our samples. So what it ends up doing is it allows us to dry our samples at very moderate conditions, which is especially good for samples that, for example, are sensitive to heat. So we're able to preserve those samples but still remove the water without having to boil it. What we use the machine for is primarily biological and chemical samples. Remove the water, and then we are able to store those samples in a dry phase or in a solid state, usually a powder, which prolongs the storage duration, and also a lot of times that is used to do analyses with these samples, such as UPLC or NMR.